Pre-calculus, section 2.1, complex numbers. Today's objectives: to add and subtract complex numbers, multiply complex numbers, divide complex numbers, perform operations with square roots of negative numbers, and to solve quadratic equations with complex and imaginary solutions. The imaginary unit, I. The imaginary unit I is defined as I is equal to the square root of negative 1, where I squared is equal to negative 1. Complex numbers and imaginary numbers. The set of all numbers in the form of a plus bi, with real numbers a and b, and I, the imaginary unit, is called the set of complex numbers. The real number a is called the real part. So right here we have the real part, and then b is called the imaginary part. Because it has the I attached to it. All right, and then complex numbers a plus bi, for the complex number for a plus bi. If our b is equal to 0, is not equal to 0, then the complex number is called an imaginary number. An imaginary number in the form of bi is called a purely imaginary number. Okay, so if we just have bi, this is imaginary. Whereas if we have a plus bi, this is called complex. It's complex because there's both that real and the imaginary portion. It's a combination of real things and imaginary things. It's complex. Whereas bi, if it's just I with a number as a coefficient, that's just imaginary. So complex is more complicated. So we have the equality of complex numbers. If we have a plus bi is equal to c plus di, these two things are equal if and only if, by the way, this is some math terminology here you might see in the future, if your a is equal to c, so if the real portions are equal to each other, and then also if b is equal to d, the complex or the imaginary portions are equal to each other. Adding and subtracting complex numbers. So if I have the quantity of a plus bi, and I'm adding to it the quantity of c plus di, this is equal to a plus c. So we're taking the real portions, a and c, and we're adding them together. Plus, we're taking now the imaginary portions and adding them together, b plus di. And likewise, same with subtraction, except, well, we need to distribute that negative. So distributing the negative, we get the minus c. Distributing the negative, we get the minus d. So in words, this just says that you add or subtract complex numbers by adding their real parts, adding their imaginary parts, and expressing the sum as a complex number. Let's go ahead. Do we do an example now? Yeah, we do an example now. Okay, here we go. So adding or subtracting complex numbers. Here we've got two different things to add. So once again, we're just going to add the real parts. So I'm going to get 2 plus 8 is 10. Then I'm going to add the imaginary parts. 6 minus 1 is negative 5i. Done. Okay, next. Now we need to subtract, so we're going to need to distribute that negative. So we're going to get a 5 minus 13, which is negative 8. Then we're going to do a 5 minus a 2, which is going to give us a plus 3i. Not so bad. Okay. Multiplying complex numbers. All right, this gets a little bit more difficult, but we can do this. Let's do it. Okay, A. 2i times 11 plus 7i. Distribute. 2 times 11, we're going to end up getting a 22i. 2 times 7i, we're going to get a plus 14i squared. But if you recall, I squared is equal to negative 1, so this then becomes a negative 14 plus 22i. And this is the correct way to write it. This is our standard form. We always put the i's last. For B, a little bit more complicated again, 6 minus 3i times 2 minus 5i. We're going to draw our rainbows. 6 times 2 is 12. 6 times negative 5i gives us a negative 30i. Negative 3i times 2 gives us a negative 6i. And then finally, negative 3i times negative 5i gives us a plus 15i squared. We're going to want to combine like terms. So these are like. So we're going to get a 12 minus 36i. Now, once again, we have that I squared, so we're going to get a minus 15. Then we're going to see that we once again have like terms. We have the 12 and we have the negative 15, so we're going to get a negative 3 minus 36i. All right, it's just algebra with one additional thing. Our I squared is negative 1. So it's just like working with x's, except for that one additional trick that I squared is equal to negative 1. All right, conjugates of a complex number. The complex conjugate of the number a plus bi is a minus bi. We take the imaginary part and we do the opposite of it. And the complex conjugate of a minus bi, so in case you're not keeping up, we're over here, is a plus bi. Once again, we took that imaginary part, the part with the I, and we did the opposite of it. We did plus bi. The multiplication of complex conjugates gives a real number. So in this case, notice how we have a complex number. We're multiplying it by a complex number, and we end up with just a real number. There's no i's there. And let's just quickly do this once. So a plus bi times a minus bi. If we distribute, we're going to get an a squared. We're going to get a minus a bi, and then a plus a bi, and then a minus b squared I squared. Well, these two things just annihilate each other because they're opposites. So we're going to get an a squared. If we do our I squared, we're going to get another negative. So negative times negative is a positive. We get our plus b squared. You can do this math every single time, or we can just memorize the rules. And the next slide is going to help us memorize those rules because the complex conjugate comes from the difference of squares. So here we have a minus bi. times a plus bi, we get that a squared plus, or a squared minus b squared. The only reason why with the complex numbers we get the plus sign instead is because the I squared gives us that additional negative. And yes, remember that's the difference of squares. The middle terms a and b, ab, and a minus b cancel out, as we saw just earlier. But yes, the complex conjugate comes from the difference of squares, probably one of the most used factoring forms in all of math. All right, so now we're going to be using conjugates to divide complex numbers. So in math, we don't like certain things. We don't like square roots in our denominators. We don't like i's in our denominators. So to fix that, we simply just get rid of them. But we need to do it mathematically. So we have this 3 minus 9i divided by 10 plus 3i. So we're going to use the complex conjugate, what we just learned about, but we need to somehow get rid of the I in the denominator. So we're going to use that complex conjugate, but we're going to use it as the number 1. What? Yes, so we're going to multiply this fraction by the number 1, but it's going to be 10 minus 3i. We switch those signs, so that way it's the complex conjugate. But since we want it to be equal to the number 1, we need to also do it on the top. If you memorize the pattern, then it's just a matter of distributing the top portion. So we're going to get a 3 times 10, which is a 30. A 3 times a negative 3i, which gives us a minus 9i. A negative 9i times a 10, which gives us a negative 90i, and then that's negative 9 times the negative 3, which gives us a plus 27i squared. On the bottom part, you just write the real parts of these squared. So 10 squared, 100, plus 3 squared, 9. Now we simplify. So we're going to get a 30 minus 27 because we have that I squared. And then negative 9i minus 90 gives us a negative 99i all over 109. And then what I'm going to do is I'm going to kind of break this up. I'm going to write this as two different fractions. I'm going to have our real parts, which is going to be a 3 over 109. Then I'm going to have our imaginary part minus 99i over 109. And now we have it in standard form. So since we're doing things in standard form, we're going to need to rewrite them always as two different numbers. In this case, they're fractions, but they're still two different numbers. So there you go. Key takeaways here: when you do the complex conjugates, you just add together the squares of the original numbers, and you legitimately add them together. There's no subtraction. You have to distribute the top part of it. So that's what we did here. We distribute the numerator, and we get all of this junk. And then finally, we need to write it as two different numbers, not one fraction. The principal square root of a negative number. For any positive real number b, the principal square root of a negative number is negative b, is defined by, so here we have square root of negative b is I square root of b. If b were a perfect square, we'd take it outside of the square root, but we don't know that, so we leave it in. All right, example 4. Perform the indicated operations and write the results in standard form. So there we go. There's our needing to write two different things here. So we have a. A is the square root of negative 32 plus the square root of negative 27. All right, let's do some factor trees. We can't use our calculators because of the negative sign. We can, but you got to get smart about it, and you need to pay attention in class for that one. All right, so here we're going to get a 32 is, you know what, it's a 16 times 2. We can take the square root of 16 because a 16 is a 4 times a 4. So this first part is going to become a 4i square root of 2. The 2 does not have a partner, so it stays in the square root. Because there are 2 4s, we can take one of them out. And I had a little pen issue there, so there we go. All right, and then plus, well, what's 27? 27 is a 3 times a 9, which is a 3 times a 3. Okay, so here, once again, we're going to get stuck with a 3 on the inside of the square root. But we can take out a 3 because we have 2 of them, so we're going to have a plus 3i. And I would say that's it. There is our standard. Oh. Well, yep. There's not really much to do here. We could always factor the I out. Because, yeah. I'll just go ahead and do it. So we have a 4 square root of 2 plus 3 square root of 3 times I. There's no real standard form for this one because they both had i's. We can't combine them because of rules about radicals, square roots. In order to add them, what's inside of the square root has to be the same. They're not, so we'll just move on. B. All right, so we're squaring stuff here. So we're going to have an I plus square root of negative 3 times I plus square root of negative 3. All right, we need to do the square root of negative 3 part first. So we're going to get I plus I square root of 3 times I plus I square root of 3. I encourage you, if you don't get it, to do the distributing yourself. Pause now and do it, because I'm going to go ahead and just use our rules for perfect square binomials. I'm going to get an I squared plus 2, and we're going to get our A times our B. So we're going to get 2i squared square root of 3. And then lastly, we're going to get a plus I squared times 3, because square root times square root is just the number that you had on the inside. So now we're going to end up with a negative 1 minus 2 square root of 3 minus 3, or simply just negative 4 minus 2 square root of 3. And that's actually our standard form for radicals. Okay, C. C is not so bad. Let's do this. Looks kind of crazy, but it's not so bad. C, we're going to get, I'm going to break up our fraction first. I'm going to get a 6 over 3 minus square root of negative 9 over 3, which gives us a 2 minus 3i over 3, or just a 2 minus I. Because the square root of 9 is 3, square root of a negative is the I, and then we can reduce. All right, last example. Let's give us some more room to work here because it is the quadratic formula. Okay. Solve using the quadratic formula. Oh, I hate the Okay, anyway, let's do this. Okay, so our A is equal to -2, our B is equal to 2, and our C is equal to -1. Because this is the form of ax squared plus bx plus c is equal to 0. Now we're going to use our quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug in. X is equal to -2, the opposite of our b, which was a 2, plus or minus the square root of our b squared, which will give us a 4, minus 4 times our a, which is -2, times our c, which is -1, all over 2a. Oh, but our a is -2. So here we get x is equal to -2 plus or minus the square root of 4. We have 3 negatives, so we're going to get a negative. 4 times 2 is 8, times 1 is still 8, all over -4. So x is equal to -2 plus or minus the square root of -4 over -4. And we'll continue. X is equal to -2 over -4 plus or minus, and we're going to get a 2i over 4. Square root of a negative gives us I, square root of 4 gives us 2, which is then just x is equal to a 1/2 plus or minus 1/2 I. And I'm going to stop there. I can write that twice, or I can leave it how it is. I'm going to choose to leave it how it is.